Now we're going to talk about reactivity. So when you're looking at the periodic table, and I drew up a funky periodic table here just for your reference, and we can dive in and look at it a little bit. These elements on the periodic table, many of them are reactive. There are some that aren't. There are some that are not reactive at all. There are some that are, they're minimal reactivity. And then you have two groups that are very reactive. So let's start by talking about the most reactive groups. We have group 1 and group 7. Those are our two most reactive groups. When you get rid of group 8, which is the noble gases, and they are non-reactive, meaning they don't combine with any other elements at all. They do not react. It's considered the least reactive group on the periodic table. When you get rid of that one, you'll notice that the two outer groups at the periodic table are the most reactive. Very interesting when you think about it like that. So how we like to point that out is by saying that group 1, how many valence electrons does group 1 have? 1. Group 2 has 2. Group 3 has 3 valence electrons. Group 4 has 4. 5 has 5. 6 has 6. And 7 has 7 valence electrons. Valence electrons means how many electrons are in your outer shell. And it determines an element's reactivity. So group 1, if it reacts, here's what happens with all of the elements in group 1, okay? Hydrogen, helium, those ones, sodium. They have one element in their outer shell, and they want to be full. They want to have a full octet. So it's a lot easier for them to shed that or share it or get rid of it, whatever you want to call it, shed that electron, and then have a full octet or a full outer orbital. So we say that its charge, the charge of the atom for all of these electrons will be 1. Or you can consider plus 1, okay? Group 2, they have 2, and they will get rid of those atoms to combine with, or I'm sorry, get rid of those 2 electrons to combine with another element or 2 to become stable. And so they will become plus 2. The pluses means that they are positive ions. And ion, if you're looking for a definition of ion, it simply means an element that gained or lost electrons. Okay? So now let's look at group 3 on the periodic table. 3 plus. Okay? We're going to do a little something different for group 4. 4, you don't need to worry about that in middle school. But for informational purposes, group 4 can either gain 4 or lose 4. But you're not going to be tested on that. Now, you will be when you get up to high school or college level chemistry, but not in middle school, so don't worry about it. But that's what group 4 does. Now we're moving past the metals, and now we're moving into the non-metal section of the periodic table. And they start doing something different. Now their outer orbitals have a lot more electrons in them. So it's easier for them to gain the electrons to form negative ions. And when you think about it, so with 5, it needs to gain 3 to have a full octet. So this is going to be 3 minus. Okay? In group 6, 2 minus. And then group 1 is 1 minus. So your outer ones, plus 1, minus 1. The next two, groups 2 and 6, plus 2, minus 2. And then groups 4, or 3 and 5, plus 3, minus 3. The right side of the periodic table, nonmetals, they gain electrons to form negative ions. And the left side of the periodic table, the metals, they lose electrons to form positive ions. We don't worry about the transition metals when it comes to reactivity. They're they don't react very often. So we don't worry about those. We worry about our main groups on the periodic table, and that is group 1, 2, 3, 4, 5, 6, 7, and 8. I do have the numbers 13, 14, 15, 16, 17, and 18 because that's what they typically are really called, in chemistry. But for our purposes, we like to say these numbers 3, 4, 5, 6, 7, and 8. It's great for learning, and you'll see questions that are like that. And that is the reactivity on the periodic table as far as the groups are concerned. Remember that groups can be called families or columns. GFC, good fried chicken, great fried chicken, whatever. That's kind of the acronym I like to use. GFC helps me remember that those are the verticals on the periodic table. And then don't forget, the rows or periods go side to side, and they don't determine anything. They don't determine reactivity at all. All they do is tell us how many orbitals an element has. But that's it, friends. That's reactivity on the periodic table. And the last point I guess I'll bring up is you'll notice when you're looking at compounds, which we will get into soon, a lot of these nonmetals will combine with metals because you have metals that are looking to get rid of their outer orbital, and you have nonmetals looking to gain gain electrons. So just like hydrogen and oxygen, you have oxygen looking for electrons, and hydrogen looking to give it away. So you're going to notice that the left side and the right side, they like to combine, like sodium and chlorine to make table salt. All right, guys, we'll talk again soon about more chemistry.